Okay, we are C2429B. I am Colin. I am the programmer and driver.
I'm Dylan. I'm one of the team's builders.
So on our robot right now, we have a slip gear. But for the competition, we're hoping to have a lift on there at the same time. But right now we have a slip gear that is powered by two motors, which are 32s to 32s. We have this little angle plate right here. The angle plate is to make it so that when it comes up, this little piece right here is also angled. When it hits the ball, this will bounce up higher, which means when it hits, this is a speed fast. So we put it down at the beginning tile, and it shoots it up and over towards the other end of the field by lobbing it. These pieces right here are just for our supports, but we chose the chassis metal because the chassis metal also allows us to put a lift right on top of this, because you're able to have a nice flat surface. And now Dylan will talk about the actual chassis.
Okay, our chassis is 18 inches by 18 inches. We have 4 motors, our microcontrollers right here, 4 Omni wheels, and our batteries right there. And it's all steel.
The reason that we chose the all steel frame was because we intended from the beginning to be a hybrid bot. With an all steel frame, it makes it so when I can put half my body weight right there, and this stuff still doesn't bend. Right here we have this bar, because as I don't have my top on right now, this bar right here stabilizes the two bars to make it more straight. And we have a power expander for our 2 motors right here. That is just because the Cortex and the read-off takes a lot of the power away from the actual robot. So with the power expander, we get more power towards our motors. And this is our notebook right here. This is a little rough sketch of what the robot looks at the moment. And down here, we use the engineering process to try to figure out which would be the best. We did the flywheel. We did the We did a push bot, a slip gear, a lift, and a block. We decided that motors were important, power was important, the speed, and how many points they could score. So with the flywheel, we determined that there'd be about 12 motors. The power would be a lot. The speed is fast, and the points are anywhere from 0 to 300. With the push ball, we determined that'd be about 8 motors, 2 per wheel, 8 motors, and then that would be a lot of power, but not a total lot of power. It'd be slow for scoring, and it could score up to about 50 points, anywhere from 0 to 50. The slip gear, 8 motors. It takes some power. It'd be fast still, but only score from 0 to about 250. With the lift, we said about 10 motors. Not a lot of power because those motors are only used towards the end. It'd be about 4 motors to up and flip over the lift. 4 motors for our drive, and that was about it. Yes, that's 8, but we would have found 2 more motors to try to put on for a slip gear. It'd be fast for scoring at the end, and it can score anywhere from 25 to 100 points. With the block bot, it'd be about 4 motors just for the wheels. It would be very, very little power. The speed doesn't really matter, and it'd score about 0 points. So we decided that there's multiple ways we could have gone with this. We could have made it so that there's a slip and a lift. We could have made it a lift block bot. Right now we're looking towards we're going to try to implement 3 of them in there. We're going to hopefully have the shooter and also the lift at the same time. And if we have the time, we will make it a block bot too. Thank you. This is C2429B.